Okay, so this is section 3.5, the final section here in chapter 3. And we're going to be talking now, instead of two variable systems with two linear equations, we're going to up the ante a little bit, and we're going to talk more about systems that contain three equations and three unknowns. Okay, and you have some notes already on the note sheet, the steps of how to do this, but basically I kind of summarized it here with this little diagram of what it says for the goal. 3 to 2 to 1 is basically what we're going to do. Alright, we're going to use elimination only here. There are some ways you can use substitution to solve three variable systems as well, but you're going to talk more about that in pre-calc. So for right now, I just want to use elimination, which is good. We're not going to go through all the different methods of solving three variable systems the way UE did with two variable systems. But generally speaking, our goal is we're going to take the three unknowns and the three equations and use elimination to eliminate one of those variables. Then we'll have a two-variable system. And then it's basically just like we've been doing all chapter. You take your two variables, eliminate a second one, solve for the third, and then work backwards to get the other two values. Alright, so follow along in your notes with these couple examples that we'll do together. The most important thing with this section, and I'm going to stress this in class a lot, you need to stay organized. It's very easy to make a lot of sign errors with these elimination problems because we're going to be doing, as you'll see in a few seconds, a lot of elimination just for one system. Okay? Use colored pencils, use colored pens, do whatever you can to stay organized with these problems as we go through it in your notes. Okay? System that we have. 2x plus 3y equals 4z equals 23. 2x minus y minus z equals 7. And 2x minus y minus 3z equals 15. Okay, so we want to eliminate one of the three variables. Life handed us a great problem to start off with because every one of these x coefficients has the same coefficient, or every one of these x terms has the same coefficient of 2. So we're going to be able to eliminate the x pretty fast. So why don't we take the first pair? I'm going to multiply the second equation by -1 because remember, when I do elimination, I like to eliminate through addition. If you don't want to do that extra step, you could subtract these two equations, but please be careful of your signs. So the middle equation now becomes -2x plus y plus z equals -7. And then I can add that up. The x's cancel. I get 4y minus 3z equals 16. Okay? Now I'll do the exact same thing with the bottom two equations. I'll multiply this time the 2x minus y minus 3z equals 15 by -1. And I get, alright, 2x minus y minus z equals 7. That's our middle equation. And then with the change of signs, the bottom becomes -2x plus y plus 3z equals -15. And I'll add. But this problem got even easier because look what just happened. Not only does the 2x's cancel, but so does the y. This won't always happen, ladies. This was just a good first example to ease you into this idea. But it looks like I actually now have one equation that's going to help me solve for z. So I know 2z equals -8, so if I divide through by 2, z is -4. Once you get one value, then you just kind of work your way backwards to get the other two. So I'll take that -4, and I'll plug it into this equation that has two letters. So now I have 4y minus 3 times -4 equals 16. 4y plus 12 equals 16. So y is 1. Now I'll take all of that, and I'm going to go into any of the three original problems, any of the three original equations from our system, plug in 1 for y, -4 for z, and figure out x. How about I use the middle because there's fewer coefficients? Alright, so it's -1 minus -4 equals 7. 2x minus 1 plus 4 equals 7. That means 2x plus 3 equals 7. 2x equals 4. x equals 2. So now instead of writing an ordered pair, my solution set is written as an ordered triple. When x is 2, y is 1, z is -4, the system has a common point. Let's try the next example. Alright, so we have -5x plus 2y plus 4z equals -23. -2x minus 4y plus 2z equals -10. And -5x minus 3y plus z equals -17. Okay, now here there's not a real obvious choice of which variable to eliminate first, necessarily. To me, if I have a coefficient of 1, just like when we did 2 by 2 elimination, that's usually going to be where I start. So I see that I have right here my plus z. So I think I want to eliminate the z's first. And even more so, in the other two equations, the 2 and the 4, well, they're both divisible by 2, so it's going to be very easy to get them to match up for elimination. So I think I want to start with the z. Alright? There's no rhyme or reason of which of the three to eliminate first. You just have to eliminate one of them from all three of the equations first. So I'll multiply the middle equation by -2, and I'll take the top two equations and eliminate the z from them. So we'll keep the first equation the same. -5x plus 2y plus 4z equals -23. And then the middle equation becomes 4x plus 8y minus 4z equals 20. I'll add them up. Z's cancel. This should be a -23. I don't want you to miss that negative sign there. So I have -x plus 10y equals -3. And I'll hold that equation for right now. Now, I'll take the bottom two equations and eliminate the z. This time I'm multiplying that third equation by -2. So the z's line up for elimination. So now the bottom equation becomes 10x plus 6y minus 2z equals 34. I add. The z's do cancel. I get 8x plus 2y equals 24. Okay, so now I'm going to take the two equations that had two variables that I just starred in red, and I'm basically going to solve that system just for x and y. Okay? Again, as we've talked about before with elimination, if you have a coefficient of 1, take advantage of it. So I'm going to multiply the -x minus 10y equals 3 by 8, and now I get -8x plus 80y equals -24, which then when I add up the red equation, 8x plus 2y equals 24, the x's cancel. I get 82y equals 0, which means y equals 0. So I got my first value. So now I'll take this and plug it into either of the two variable equations we have. Though I think you're going to be able to visually see what the answer is going to be for x. So if I make y 0, I get x is 3. So I know that. Now I need to go back to one of the three originals and plug in 3 for x, y for 0, or 0 for y, and figure out what z is. So if I use the top equation, -5 times 3 plus 2 times 0 plus 4 times z equals -23. -15 plus 0 plus 4z equals -23. Running out of room, I'm just going to skip the step of the algebra here, bring the -15 over, and I get -8. So z is -2. So my ordered triple for this system is 3, 0, -2. -3x minus 4y plus z equals -3. 2x minus y plus 3z equals 13. X minus 2y plus z equals 7. Alright, so in this case, I actually have one letter that has a coefficient of 1 in each of my equations. So I really have a choice of what I want to do here, of how I want to eliminate. I'm going to use the x first. So what I'll do is I will multiply the bottom equation by 3 and pair it up with the top equation so I can get the x eliminated in that pairing. So my new bottom equation becomes 3x minus 6y plus 3z equals 21. When I add them up, the x's cancel. I get negative 10y plus 4z equals 18. And I'll hold that equation for right now. Now I will do the same with the second equation and the bottom equation. This time I'm going to multiply that second equation by negative 2. So that way the coefficients of x line up to be opposites for elimination. So the middle equation I keep exactly the same. The bottom equation becomes negative 2x plus 4y minus 2z equals negative 14. I add, the x's cancel. I get 3y plus z equals negative 1. Okay. Now I have to choose between my black line and my red line which variable to eliminate from that system. The z makes the most sense because in the red equation I have a plus 1. So if I multiply this by negative 4, I keep the negative 10y plus 4z equals 18 the same. But now I get negative 12y minus 4z equals 4. I add, I get negative 22y equals 22. So y is negative 1. Now I can go back to either of these two equations and make y negative 1. I'll use the red one because the numbers are a little bit easier to work with. So I get that z is positive 2. Now I can take the fact that z is 2, y is negative 1, and work with any of the original 3. I'm going to work with the bottom one because, again, the numbers are a little bit smaller to work with for the algebra. So I get x plus 2 equals 7, x plus 4 equals 7, so x equals 3. So my order triple here is 3, 2, negative 1. Whoops, I reversed that, sorry. It should be 3, negative 1, y comes first, comma 2, okay? X, Y, Z. Don't make the mistake that I just did there. Put them in alphabetical order. Alright, so with that, have a go at some of the practice problems that are on the other side of this note sheet. I strongly recommend, you may not be able to fit all the work on the sheet that I gave you, do this in your notebook. Again, the most organized you are, the cleaner you are with doing this, the easier it will be to be successful the first go around, or if you're not successful the first go around, it'll be easier for yourself or myself to take a look and try to find out where your mistake is. Okay? With that, bring any questions to class tomorrow and have a good evening.